Air versus liquid cooling, settled with real degrees and real decibels. On the same chip, one runs 20 degrees Celsius cooler under load, and idles about 5 decibels quieter. But only sometimes. Here's exactly when. Here's why this fight matters. A modern chip only runs fast while it stays under its heat limit. Cross it, and the chip slows itself down to survive. So cooling isn't comfort. It's your speed cap. You feel it two ways: how many frames hold steady in a long game and how loud the fans get at your desk. And a desktop and a laptop play by completely different rules. Start with air because almost every PC ships with it. The trick is moving heat off a tiny chip fast. Sealed copper tubes touch the chip. Liquid inside them boils, races to the cold end, and dumps the heat into a stack of thin metal fins. A fan blows air through those fins. That's it, no pump, no power beyond the fan. Those sealed tubes have a name: Heatpipes. A strong setup, like a big dual-tower cooler in the Noctua NHD15 class, can handle roughly 250 watts of chip heat while staying quiet. But air has a hard ceiling and it's physical. The fins and fan can only grow as big as the case lets them. Push past that and there's simply nowhere to put more metal. Worse, the fan doesn't remove heat from the case. It just shoves it off the chip and into the box around it, so the whole inside warms up and every other part breathes hotter air. The upside is real though. Air is cheaper, there's no pump to buy and nothing that can leak, and you bolt it on once and forget it for years. So if air is this simple and this reliable, why does anyone bother pumping liquid through a computer? Now the reason people run liquid. It solves air's biggest problem, where the heat goes. A metal plate sits on the chip and soaks up its heat into liquid. A small pump pushes that warm liquid down a tube to a radiator bolted to the case wall, where fans blow the heat straight out of the box. The sealed pre-filled kind is called an AIO, all-in-one. And the radiator size is the whole game. A common 240mm radiator is fine for most chips. Step up to a 360mm, and you've got roughly 50% more surface area throwing off heat, which is what lets it tame the hottest chips that make air coolers choke. Two real wins here. The heat leaves the case instead of cooking your other parts, and that big radiator gives you far more cooling surface than any fin stack that fits inside. But nothing's free. That pump is a new noise source that hums whenever the PC is on. It's a moving part that can fail years down the line, and the whole kit costs more than a good air tower. So it moves more heat, but does that actually turn into a number you'd notice? Here's the number everyone actually wants. Put a top air cooler and a good 360mm liquid setup on the same hot, high wattage chip and run a long, punishing load. The liquid setup lands around 20 degrees Celsius cooler. That 20-degree gap is the headline of this whole comparison. Then the noise. Because liquid can shed heat easier, its fans don't have to spin as hard to hit the same temperature. So at matched cooling it can sit roughly 5 decibels quieter. 5 decibels is the difference between a fan you notice and one you don't. And this is where most reviews mislead you, that gap only exists at the top. At low and medium loads a good air cooler is dead silent, and it can actually beat a liquid setup, because the AIO's pump keeps humming no matter how gentle the task. There's no pump on an air cooler to make noise. So the honest verdict is narrow, that 20 degrees Celsius advantage and that 5 decibel edge really only show up near the ceiling, an overclocked chip, or something pulling 200 watts or more. Below that, you're paying for a gap you'll never feel. Which raises the real question, does any of this even apply to a laptop? Now the laptop, because it's a different world entirely. There's no room for a tall tower or a radiator in something a couple centimeters thick. Almost every laptop cools the same way. Flat heat pipes carry heat to a tiny finned edge, and small blower fans whip air out the side. It's all air, just squeezed into a sliver of space, which is exactly why laptops spin up loud and fast the moment you push them. Liquid cooling in a laptop is rare and awkward. Usually an external dock you plug into, or a fancy vapor chamber hybrid in a few thick gaming models. So for almost everyone, the laptop choice isn't air versus liquid at all. It's simply, how good is the air system this machine already has? And that changes what you should actually do. Fussing over cooler type is the wrong move on a laptop. Lowering the chip's voltage so it makes less heat, refreshing the dried paste under the hood, and setting the thing on a cheap cooling pad move the temperature far more than any label on the box. So where does all this leave you when it's time to buy? So here's the whole thing clicked together. Liquid genuinely wins, but only where the title says it does. On an overclocked or 200-watt plus chip, a good 360mm setup runs that 20 degrees Celsius cooler and idles about 5 decibels quieter, and nothing else touches that. But for a mainstream desktop chip, a quality air cooler matches its performance for less money, with no pump to buy and nothing to leak. Both hit a wall and the walls are different. Air is capped by physics. The fins can't outgrow your case and every watt it moves warms the box around it. Liquid is capped by that pump. It always hums, it costs more, and it's the one part that can quietly fail 3 or 4 years in. So the decision rule is plain. Pick air. Only reach for liquid if you're overclocking, pushing past 200 watts, or you want the quietest possible desk at full tilt. For everyone else, the expensive option cools a problem you don't have. So the fight is settled with numbers, not adjectives. 20 degrees Celsius cooler and 5 decibels quieter, but only near the top. Otherwise, pick air. Next, we open two setups that break these rules entirely. Custom loops that cool a whole rig on one liquid line, and the vapor chamber mods squeezing more out of a laptop.